My name is Jake Ginnivan. I am a tech lead at Seven West Media. Our team actually uses TypeScript heaps. We're all in, and one of the least common sort of understood TypeScript things is generics. So I had two options of what I wanted to present tonight. The first one was going to be generics or some other TypeScript features, and the other one was JavaScript debugging. So depending on how many questions I get towards the end around generics and TypeScript in general, I might jump into debugging JavaScript as well. If anyone has any questions, please yell out as we go. I want to try and demystify this little bit of TypeScript. Out of interest, who uses TypeScript here or has an interest in learning a bit? Okay, probably just over half. So I'll keep it I won't be too long for the people that are not interested. So generics are one of these really cool features that you use all the time when you start using TypeScript, and you don't even realize you're using it until you have to dive in and write your own type definitions or whatnot. So for those that don't realize what TypeScript is or know what TypeScript is, it's a language that builds on top of JavaScript that gives you a static type system. So what that means is JavaScript is a dynamic language. Anything can be assigned to anything. There's kind of no real rules, and it all blows up when you run your code. The idea around TypeScript is you explain the shape of your code, what functions look like, what parameters they have, and then you move all of these things that blow up at runtime, you move it to a step before you actually run your code compile time. So that's kind of the goal of TypeScript, is to move these runtime errors across into like type check or compilation errors. Let's dive straight in then. There's two types of generics, or two ways that generics can be used. The first one is using generics in objects. So a scenario is I've got a button on my web page, I click on it, and I get a click event back, right? Pretty common. So how do we describe a click event? Well, in TypeScript, you have interfaces, and they describe the shape of an object, and I'll just call this an event. An event can have a bunch of stuff on it, so it probably has a prevent default, which stops the event from bubbling. You also have a target. So if it's a button click event or it's a click event, this could be the button itself. So we'll just say this is an HTML button element. Oh, it's blowing up here. I'll call this my event, because there is a global event somewhere else. Cool. Now, the problem with this particular event is I can only use it for buttons. What happens if I add a click handler on a div or some other HTML element, right? So this is the first scenario that generics become really, really useful, is I can say, okay, I want my event to be of something, so it can work against some other type of data. So I'm going to make it generic of T, or I could call it something more useful like T element. Just like you have variables and parameters in functions, you can actually use your generic parameter anywhere in your type definition. So instead of having a HTML button element, I'll just go, this is a T element. So now when I have a type button event equals my event of HTML button element. So now I've created an event using the shape of my original event, but it's specific to buttons. I can also go like div event Cool. So this is the first scenario. Really useful, allows you to create a reusable shape that describes your JavaScript object, but make one part of it be any specific shape. Does that make sense to everyone? Cool. So this is the first real use case for generics. The second one is where people start getting a little bit more confused, is when you can use generics in functions. So to start with, I'm going to have an array. And my array has 3 values in it. It's got 1, 1, and 2. Right? I then want to just create a function that is a distinct function. So I'm going to go function, distinct, and I'll take the items. In TypeScript, you have to declare the type of things. So I will say this is an array of numbers. You then specify the return type, which is another array of numbers. I then need something to return. So I'll say the result is an array of numbers. I'll initialize that to an empty array, and then I will return my array of numbers. Then to actually write the implementation, I'll just do a for of item of items. Please yell out if you don't follow any of this. I'm going to be opening it up for questions after. And then if I don't already have this item, I'm going to just push it into the array. All right? So this is my distinct function. I can test it using a really, really cool tool. You'll see all these green lines, green dots down the side. This is using a tool called Quokka.js. It turns VS Code into like a code scratch pad, similar to like LinkPad if you're from .NET. So I can actually just go distinct array, and then I can put a comment by just going like / question mark, and it will evaluate the results. So you can see that when I call this, I get my distinct array of 1, 2. It's all live, so if I put 3 in here, it'll reevaluate, and I should see it not work. Let's try that again. Cool. So you can see it's reevaluated, and now if I put in a 4th, you can see it actually updates. Sweet. The problem with this is if I have a different type of list, so down here I go const array 2, and it's got strings in it of 1, 1, 2, and I try and call distinct, I get a compilation error saying an array of strings is not assignable to an array of numbers, right? Because they're 2 different types. My function only knows how to work against numbers, not strings. This is where the other type of generics comes in. I can make this a generic function, so I can keep the implementation the same, but change the type of data that it works against. The way I do that is say it's a distinct, whenever you see the like triangle brackets, the way to say that is like of, so this is a distinct of t. I'm not sure why it's called that, but anyway. And then just like the other object generic, I can now use t anywhere within this function that I'm declaring types. Just like if you have a parameter to your function, you can reference that anywhere in your code. This is TypeScript one step before, like a meta description. So I'll replace all 3 instances of number with t. Now I go down to my distinct array 2, and my distinct function works against numbers or strings. Cool? Makes sense? So they're the 2 types of generics. Where they become really, really cool is where you do something more interesting. So rather than here saying, okay, this is just going to work against primitives, like if they're the same value, what I want to say instead is put a generic constraint on. So what does generic constraint say is that this T must look like something else. So I'll say it must look like an item that has an ID. You'll see both of these will actually fail now. So we'll just get rid of that. And I'll make a new array. And it is ID 1, ID 2. Wait, did I say ID of number? You can also make this have name Jake. It's now just a bunch of objects that it's just a bunch of an array of this objects, and the only common thing between them is they have an ID property. I now want to make sure that this actually works. So I can say array.sum. Because of generics, it knows that the items is an array of T, and T has a property called ID. So this is how IntelliSense kind of works. It knows that my array is working against an object that has this shape, and it tells me that, okay, it has a property called ID. And I'll just validate that, does the result have an item in it that the ID matches? Everyone following along? Cool. So now, if I call distinct and pass array2, my distinct function now works against any sort of JavaScript object that contains ID. So that's generics in a nutshell. Really, really evidently simple feature, but can become really confusing when you start seeing all these angle brackets and objects everywhere. So, any questions around this?
I have a question, but not really on TypeScript. I haven't seen sum too often.
Which one?
The sum function. Yeah, result.sum.
This one. Okay, so the sum function is, the question was, haven't seen sum before. It's part of ES6. So JavaScript has new versions that come out every year. So a couple of years ago, they created a new version, ES 2015, and it came with a whole lot of new language features. Now, every year, updates come to the JavaScript ecosystem. That's another role of TypeScript, or Babel, is to allow you to use these new features in the language and still deploy your web app not targeting these cool new features. But what sum does is it just allows you to basically pass it a function that if it returns true, similar to the map, but if any of the items match, like return true for that function, it will return true. So if you've used .NET before, .any in link is the same. But yeah, does that answer the question?
Yeah, it just looked like there's not something cool there.
Yeah, it's has everyone played around with ES6 out of interest? Yeah, ES6 is awesome. You've got arrow functions here which don't have a this in scope, so you don't have to worry about rebinding this and a bunch of other stuff, but it's really, really nifty. Any other TypeScript questions?
Build targets.
Build targets.
So when you compile with TypeScript to JavaScript,
Yep.
which constraints do you put generally?
Okay, so I have another project over here. So in TypeScript, you have something called your tsconfig. So your tsconfig allows you to define what bits of, well, what settings your TypeScript project has. It allows you to specify your target. So here, I could go, okay, I want to compile to ES3, and then I can use really new language features like object spread and async and await, and it will actually generate code so that can run in like IE6. Pretty crazy. ES5 is the safest because if you support Internet Explorer, it supports ES5. Edge supports most of ES6 now.
Object spread.
Not object spread. Yeah, well, that's sad. Unfortunately, ES6 is still not there. Like, so many Android phones don't support it. A bunch of ES6 features aren't supported by Safari as well. So for us at the West, we still have to target ES5, unfortunately. And I think that's going to be the case for quite some time, which is really, really sad because the gap is getting bigger. And the downside is when that gap is bigger, to support all these new features, your compiler has to generate a heap of code behind the scenes, which means the older browsers are just running heaps more code, and that slows everything down. So, yeah.
Can you have multiple targets?
The question was, can you have multiple targets? And the answer is no, not for each compilation can only support one target. So we support, we do React and server-side rendering. So we actually do a build for the server, and that supports ES 2018 because Node supports that. And then we do ES5 for the browser. And they're two separate compilations and Webpack builds.
In terms of, you know how I said, like, you have an old browser? Couldn't you, on the front end, put it to load a certain script?
Yeah, so there are ways to get around it. It depends if, there's two types of incompatibilities you'll have. One of them is a library incompatibility. So an example is .sum. That's not a compiler feature, that's just a function that is on an array. So to support things like sum and find and all of these new helper functions, you can actually polyfill them in the browser, and that's really handy. Then if you want to use things like async and await or object spread, if you don't, like for instance, object spread can get compiled out to object.assigns, and the compiler will do that behind the scenes. But if you target ES6, it'll just put that straight out. You can't polyfill syntax. You can only polyfill libraries. So that's the distinction there. Any other questions? Right at the back.
Can you take your generics and attach them to like a prototype?
Can you take your generics and attach them to a prototype? So the interesting, I'll take a step back and answer it with TypeScript completely removes itself at compilation time. So .NET has runtime types. So you can actually use things like reflection to ask what the type information is. TypeScript removes itself and doesn't actually emit anything. So so when you're limited by the type system of JavaScript, so type of blah, instance of blah. As soon as it's compiled, you actually lose all of that type information, so there is no runtime generics. It just checks at compile time, removes itself, and emits JavaScript. Cool. I hope that was useful. Explained a few things about TypeScript and generics, hopefully demystified it. So if you do want to jump into TypeScript, one less thing to worry about.